Physics chapter 19, theory video 5. We are going to discuss about internal energy. So obviously you can remember that internal energy is the definition given for the two forms of energy that would be contained inside an object. The first one is the kinetic energy, the other one is the potential energy. So the sum of the average kinetic energies and the potential energies is going to be the internal energy, right? And you need to understand that all matter, there are situations where you might not, but in the future you might realize that there are some things that would not fall into this particular category. But for all matter, everything is made up of particles. So these particles, in a loose scientific manner, all things are made up of molecules. Yeah, and this matter can have energy, right? And so this energy can be of two different forms: kinetic energy and potential energy. So you know how to find them both, and you know the equations. So the sum of their values, mgh and half mv squared, will give us the internal energy, right? So then we can now, because we know that kinetic energy is equal to half mv squared, we can increase the amount of energy or the internal energy in it by increasing its velocity. So half mv squared. So velocity means we can increase its kinetic energy. So if we increase the kinetic energy of that, if we increase the energy content in that, it will increase its kinetic energy. So how do we increase the kinetic energy? By heating it, by providing some sort of a heat energy. Now this particular stone that is shown here, so we are heating it. So where does this heat energy go, right? So then we can, in a basic sense, the stone is not going to melt, right? Because now we are holding this stone here. So as a result, the gravitational potential and kinetic energy of the stone itself does not increase, right? Because the stone is going to remain in the same position, right? So what happens to the energy that we provide, right? So we know that molecules have more energy. So obviously you know what happens to that energy. Molecules have more energy in a molecular sense. We are not looking at the entire stone now. We are looking at the individual molecules in it. So that would have both kinetic and electrical potential energy. That would be higher because they vibrate more and faster, right? And they are a little further apart. So when they are further apart, you know what happens to them. Their electrical potential energies are higher. So as a result, the internal energy will be higher. So the internal energy of a system is the sum of these electrical potential energies and the kinetic energies, right? Then we come to molecular energy. So now there are different phases of matter. Solids, liquids and gases can be identified differently from the arrangement, order and motion of their molecules, right? And we can say that they are in three phases, right? In these three different phases, they have kinetic and potential energies, right? So then now the problem is figuring out how much of internal energy is they are in matter. So to do that, we have to add the kinetic and potential energies, right? So now, so what we have to do is we have to take a sample and find out how many molecules are there and find out each molecule's kinetic energy and the electrical potential energy, and you get the sum of all of it. So that will give us the internal energy, right? So here there are a few molecules in this. So you find out their internal kinetic and potential energies, then you get the internal energy. Right. Then we have to figure out how to change the internal energy, right? There are two ways that we can increase the internal energy of any gas, right? We can either heat it or we can do work on it by compressing. Doing work means we bring them closer, right? When you heat a gas, what happens is the molecules will start vibrating more vigorously. So as a result, they start bouncing off the walls faster and they have gained kinetic energy. So the temperature has risen, showing us that the total internal energy has increased. Then we can compress them, right? When you push them together, right? So then what happens is, now again the wall of the container is pushed inwards, right? Again the temperature rises, right? When a gas is compressed, it becomes hotter or warmer, right? So when that happens, the same principle just like in A happens. They start colliding more often, and as a result they will increase its kinetic energy as well. But these are the most obvious ways of increasing internal energy, by passing electric current uh, and there are other methods that we can follow to increase the internal energy. But here we are basically concentrating on heating and compressing or doing work on it. Then the opposite of that is, how do we decrease the internal energy? By increasing the volume or by cooling it, right? So by doing work against the gradient will give us a lesser internal energy, right? I hope you understood. If you have any questions, please ask me questions, right? Then we come to first law of thermodynamics. Before we come to that, let's write a note on this, and then in the next video, let's figure out how to do this. Write down internal energy. All matter is made up of particles, within brackets molecules, and these particles have two forms of energy: kinetic energy and potential energies. This potential energy can be of different forms, yeah? You know them. Gravitational potential energy, electrical potential energy, etc. Within brackets, right, mgh and half mv squared. The sum of these potential energies and kinetic energy would be the internal energy. Put a star and write down the definition. Internal energy is defined as the sum of the random distribution of kinetic and potential energies of its atoms or molecules. Internal energy is defined as the sum of the random distribution of kinetic and potential energies of its atoms or molecules. Leave a line and write. Solids, liquids, and gases differ with each other in their arrangement, order, and motion of their molecules. This results in the formation of three distinct phases. Three distinct phases, and is characterized by the amount of internal energy it contains. And is characterized by the amount of internal energy it contains. Leave another line and write. Internal energy can be increased by several methods. A gas can be heated or done work on it within brackets by compressing it. Both these situations will increase the internal energy and will demonstrate it by increasing its temperature. Leave a line and write. The internal energy of a gas can also decrease by losing heat within brackets cooling or expanding in a higher volume within brackets doing work on its surrounding. I hope you understood. We will come back to the first law of thermodynamics in the next video. If you have any questions, please raise it.